Good afternoon, ladies and gentlemen. I am Mizushima of TMC Powertrain Company. I would like to thank you very much for coming to this technology presentation on our new powertrain. First of all, I would like to touch upon the background before the announcement of this new powertrain, as well as our future initiatives as the powertrain company. First of all, our environment that surrounds us, and I would like to tell you about the Toyota initiatives as well as the powertrain company's initiatives and the new powertrain itself. Let me first touch upon the background of the initiative and the environment. Let us look at the global environment. You can see that there is the deterioration of the urban air quality as well as warming gases, which cause abnormal climate phenomena which are a threat to our daily life. This graph shows the global GHG emissions. As the emission continues to increase, the global surface temperature is likely to go up by 2100 by 3.7 to 4.8 degrees Celsius. In other words, globally, the serious impacts will be held due to this climate change. As you are aware that countries of the world are collaborating in order to contain this temperature rise to less than 2 degrees. But in order to achieve this, we have to rapidly reduce CO2 emission, and then we need to control it ultimately to 0 or less. In other words, we have no time to hesitate. So this chart shows this the future forecast with regard to this the fuel consumption control regulation as well as the regulation of emission. The fuel economy regulations are becoming more and more stringent, and unregulated countries are considering to introduce the regulations equivalent to the advanced countries. Therefore, the energy conservation technology needs to be deployed globally. With regard to the emissions regulations, we expect that to be more stringent. So the Japan, the North America, Europe, and China, as well as the other countries, will consider the tightened regulations. So the Toyota needs to respond proactively, taking into account this changing environment. Let me now touch upon the Toyota's initiative. Last fall, that in order to contribute to the realization of the sustainable society, last fall we have announced this Toyota Environment Challenge 2050. Toward the year 2050, we have launched those challenges, namely that the zero CO2 emission for new cars, life cycle zero CO2 emission in all, and zero emission of CO2 in all plants. And then we'd like to reduce the CO2 by 90% by 2050, and then we'd like to make the CO2 emissions zero in the global plants. On the other hand, we would like to enable the drivers to enjoy comfortably the driving performance as they wish. We'd like to pursue this fun of driving as well as create the ever better cars. And that is also the important mission for Toyota. Conventionally, that the energy conservation as a fuel diversity were actions we implemented. But we believe that when widely used eco-friendly cars will make contribution to the environment. But we have to also at the same time pursue the joy of driving. And so achieving the two goals at the high level, we believe is important. To achieve that in case of hybrid, in order to promote the use of hybrids, we continuously implement that, improving the fuel economy as well as the cost reduction. We have announced the fourth generation Prius. Its fuel economy is 70% better than the first generation Prius in terms of Japanese test cycle, and at the same time the hybrid system cost was markedly improved compared to the first generation Prius. So we like to continue to evolve in the future and promote the development at the same time. We like to improve the cost performance, but we would also like to enhance our lineup in order to respond to the broad range of customers' requests. We would like to have the hybrid vehicles for all the categories, and so that everyone can enjoy the hybrid vehicle close to them and have an option to choose. That's our initiative and efforts. In 1997, the first generation Prius was launched, In the last 20 years, we have evolved the hybrid system as well as enhanced the lineup. Cumulatively, we have provided the 9 million units of hybrid vehicles, and then we have made a contribution to the environment, namely CO2 cumulative reduction of 67 million tons. So this was announced in the Toyota Environment Challenge 2050, namely by 2050, the new vehicle CO2 emission will be reduced by 90%. EV and xEVs are the next generation vehicles which are to be promoted and developed. But naturally, the conventional engine vehicle, as well as the expected increase of hybrid and PHEV vehicles, majority of such vehicles still are mounted with engines. So we would like to further promote and evolve the engine and transmission, and because that is our contribution to the environment in terms of CO2 emission reduction. On the other hand, we have launched TNGA starting with Prius. We changed the vehicle from the frame, and we like to enhance its dynamic performance, and then its basic performance is run and turn and stop. That also were enhanced. In addition to the newly established platform and its deployment, we have the Powertrain, maybe engine, transmission, hybrid powertrain. Those will be renewed and deployed further, so that for many customers, we like to provide a car which are even better cars, which make the customers feel like they like to keep driving. So let me now touch on our initiative in terms of a powertrain company. So this is a concept of a new powertrain development. The basic the development approach of TNGA is that there's unchangeable basic frame as well as the parts that will evolve. So the basic frame will be further enhanced fully so that its fundamental parts, performance and quality will be enhanced. Using this basic frame, the component technology will be added and modified so that we will adapt to the changing environment and product needs and local needs. Toward the future, we like to further introduce the technology innovation. Meantime, in order to deliver the products expeditiously to customers, that we like to enhance the development efficiency as well as the speed up the production as well. To do that, not just the development area, but the production technology and the plant innovation as well as the change the way we work will be introduced. In other words, all these things are to be implemented simultaneously and were implemented as well. So what is a goal of a company to be through TNGA in terms of enhancing product marketability? We like to let many people to feel the attractiveness of the vehicle running, that we like to achieve this direct and smooth, excellent driving performance, as well as to achieve the high environment performance which is needed by the society. So we like to strike the two goals at the same time. And also the basic performance like engine and transmission HB system should be greatly improved at the same time. In order to deliver expeditiously many products to customers, we would like to unify the product structure as well as the processing standards, so that we like to innovate the manufacturing monozukuri, so that we like to globally deploy the production line based upon the new concept as well as the rapid and flexible implementation. And also we like to differentiate from others in terms of the value-added component technology. And then with regard to component technology concerning basic frame, we like to introduce more modularization to enhance the development efficiency, so that we would like to quickly develop the new powertrain and then deploy it to the new vehicles. So we have two overall directions as to the enhancement product marketability. First is a high environment performance. With regard to the overall powertrain, we like to pursue the better fuel economy, but we like to achieve the clean and globally the environment-friendly performance. We like to individually implement the better fuel efficiency for engine and transmission. We like to consider the size of the vehicle and the way it's used, so that the more optimal powertrain will be selected for each vehicle, so that the overall optimal fuel economy should be achieved in this development effort. And also, we like to enhance the fundamental parts of the engine combustion as well as the basic performance, so that we do not over-depend upon device, but rather at a higher level, clean performance can be achieved. Let me turn to the direct and smooth. smooth and the as you wish starting can take place, and it is a linear driving based upon the will of the driver, and it is rhythmic and comfortable the acceleration, which will appeal to the sense of the drivers. That's our target, so that overall the powertrain hardware software should be optimized so that the drivers can feel like they like to keep driving. And so our aim is always ever better car. So now I'd like to touch upon the production efficiency improvement of the TNGA, which is linked to the product innovation, which is the core of the monozukuri innovation. So we'd like to quickly respond to flexibly to the customer needs. In other words, we unify the processing standard and an assembly standard so that we have newly developed a new production line where the multiple models can be flexibly produced. And then we like to unify the production process and then lines and the specification, and so that global lines can quickly switched. That is the annual vehicle level of the 1 million units, and that is globally applied. So this is the way of thinking of the monozukuri innovation of TNGA, and I'd like to show you this flexible production system based upon this the screen. So please look at this screen.
This is the cylinder block of an engine, and we take this production as an example. Through innovation of various production processes, various engine parts, large and small, can now be produced at high speeds in a flexible manner. We can respond flexibly to changes in powertrain due to changes in the environment or customer needs. That is, we can respond flexibly anywhere in the world. Also, as part of innovation in monozukuri, or the way of making things, we made production facilities more compact, reduced space and energy consumption all at the same time. That is, the line can be completed with less investment than previously and also reduce plant CO2 emissions. We have been making efforts to develop environmentally friendly manufacturing on the production floor where powertrain is born. Next, I'd like to talk about the increasing of development efficiency with the engine as an example. So in line with the needs and characteristics of cars, various devices and structures have been chosen. By synchronizing the renewal of car platform and all of the powertrain, the center of gravity can be lowered, and it is also possible to standardize the structure for optimal loading. And in line with that, the combustion chamber and cylinder design were also standardized. And by combining cylinder capacity and the number of cylinders, we could also realize engine variation. We could then eliminate redundancies where before another model existed with the same displacement. And through such consolidation and streamlining, the number of engine types developed can be reduced about 40%. And it is combined with hybrid systems, and that is an attainment of 40% efficiency. And along with realizing the efficiency of development, we can also attain higher productivity. And from here, I would like to talk about the powertrain company development system. In other words, the transformation of the way we work. In the site of powertrain development is the powertrain development and production engine building. And centering on the integrated development office, the top floors are for prototype and production method development area and function evaluation area, and the lower floors are the areas for vehicle evaluation and powertrain evaluation. And in the Integrated Development Office, there is a unity of engineering, production, technology, and the plant. And there is a large-scale interdisciplinary office where issues are resolved together for faster decision-making. And in the engine transmission hybrid system, project-related personnel joining on one floor, we can maximize performance and functionality as well as efficiency of development. And for prototype and production method development to evaluation, It can all be completed in the same place, and therefore we can confirm Genchi Genputsu by all the relevant personnel, and that is also leading to human resources development. And with that, integrated development has been achieved through the complete sequence from advanced development to manufacturing, and that has led to speeding up the process. Toyota in the past had felt that we should create advanced technology by ourselves, and we had promoted the in-house creation of core technologies. And we will, of course, continue the in-house creation of core technologies, but in dealing with the product diversity, there will be further reinforcement of collaboration with Toyota Group and suppliers. To be more specific, we will share scenarios for development and alignment. There will be a distinguishing between the shared strategy and unique development. We will share issues and accelerate ever better cause. And with that, we can maximize the synergy of Toyota as a whole and promote the pursuit of environmental technology and fun to drive, and also deal with the diversification of power drive. And as I have explained, powertrain development and production efficiency and the transformation of the way we work will be promoted, and with the resources that have been freed up, we can have a cycle where we can reinvest the resources into the next generation car development and secure international competitiveness. By reforming the stance on various initiatives implemented through TNGA, and in order to speedily launch into the market advanced technology, we will rigorously select technologies that Toyota should independently hold and bring manufacturing in-house so as to bring advanced technologies to markets more rapidly. We will also expand joint development fields within the group to rapidly advance advanced technology. In the 5 years until 2021, we will increase the number of development personnel by approximately 30% for hybrid technologies, which are core technologies for electrification, and reinforce development systems for the future. Finally, our view on Toyota's environmental technologies will be explained. Hybrid, since Prius was launched, it's now about 20 years, and the use of hybrid vehicles in Japan, US, and Europe is increasing, but have not become particularly widespread on a global scale. It will take some time before the effects of increasing zero CO2 emissions electric power vehicles usage will be seen. However, reducing CO2 emissions is a crucial task for stopping the negative progression of global warming. Right now, vehicles with conventional engines account for the bulk of the market. Hybrid vehicles and plug-in hybrid vehicles also use engines, and consequently fossil fuels will continue to be used as an automobile fuel for quite some time into the future. Therefore, Toyota believes that conventional powertrain technology development will have a reliable and steady and actual effects towards reducing the CO2 emissions. Now, from here, I would like to introduce the new powertrain that we are announcing this time. In TNGA, in order to improve the basic performance of automobiles, the platform, which is the frame of the vehicle, the engine, which is the heart, transmission, hybrid systems, and powertrain units were newly developed together and updated. And the development of the new powertrain was conducted through these two pillars. And that is, we are achieving both astounding driving performance and high environmental performance, and direct and smooth, aiming to change Toyota's driving performance. And the new powertrain that will be explained in terms of the technology this time is engine and transmission, which will be presented as world premiere. The new 2.5-liter dynamic force engine combined with the new transmission, or the direct shift 8AT, and we've already announced the direct shift 10AT, and also in the new hybrid systems. The next generation hybrid system THS II will realize overwhelming driving performance, and combined with the dynamic force 2.5-liter engine shown earlier, The next generation Toyota hybrid system THS II, realizing a top fuel economy, will be introduced. And these new powertrains, and for them, in the 5 years up to 2021, we will introduce 37 new variations of 19 models. And in 2021, 60% or more of vehicles sold will feature new powertrain components, reducing CO2 emissions by 15% or more. Now, in regards to the powertrain that has just been introduced, the details will be explained by the Vice President, Mr. Kishi.
Thank you very much. I'm Kishi of Toyota TMC Powertrain Company. So thank you very much for coming to this technology presentation on our new powertrain. Thank you again. And so I'd like to touch upon the new powertrain technology. The first is this overall system of the powertrain, and I'd like to touch upon the individual powertrain unit, and I'd like to talk about the future deployment. The first, the new powertrain trains. So this is a new powertrain system development, as has been touched upon earlier, consists of the two pillars as important themes. So based upon those themes, I would like to explain how we develop this new powertrains. So based upon TNGA new powertrain is to be launched. The first one is the new 2.5-liter engine and the 8-speed AT as combination, and new 2.5-liter engine and the new Toyota hybrid system in combination. Based upon that, the fuel economy is improved by 20%, and then the dynamic performance is improved by 10%. So you can see that from fuel to the work of running the vehicle, that there's a losses incurred in the powertrain. So this is a simplified chart showing that conventionally Toyota has sought to maximum improvement of the efficiency of the engine and transmission. And TNGA, we had a technology of loss reduction so far, but we evolved it further, and in total, as a powertrain, system efficiency was maximized from the low RPM to a high RPM. Broadly, both fuel economy and driving performance are to be improved. The approach concept is shown here. First, the engine thermal efficiency is further heightened to the low RPM, and the low fuel consumption will be expanded, and at the same time, engine torque is improved. So the wide gear range is assisted for the transmission, so that the higher the thermal efficiency area will be utilized. And in addition, the control will have a higher responsiveness. Therefore, the loss due to the wider gear range could be minimized. And this is our aim here. So I'd like to further touch upon this engine. In the all ranges, the thermal efficiency, the torque are improved, high efficiency, and the multi-shift transmission combined. Therefore, we try to maximize the powertrain system efficiency. On the other hand, the direct and smooth is another concept that is against this accelerator opening, that there's a forward and backward G behavior. As shown on the right side, that the blue line shows the conventional behavior, which is now improved. The starting, and following, and overtaking in all the scenes, it has a direct response to the intention driver. In other words, the smooth and an as-you-wish type of the driving is now realized. Specifically, you see at the start and the following driving is an example here. So you see the linear road performance is shown in this screen. Motion picture, as you see, it reflects exactly as the driver wish. Next, I would like to introduce you the acceleration, which is rhythmical and pleasant. So this is the picture of this actual driving on the test course. You see that acceleration in a dynamic manner, as well as the engine RPM is increased in a rhythmical mode. Direct and smooth driving is something we can look forward to. So now I would like to tell you about the individual new types of the engine, transmission, and hybrid. First is engine. Based upon the TNGA, the newly developed engine series are here, and it's named as dynamic force engine. In the future, we will deploy the new type of this engine series of the different level of the displacement. So environment performance as well as output performance are significantly improved in this powerful new engine. So this is a concept behind this development. In order to improve the thermal efficiency, the fuel losses must be reduced. Based upon acquired experiences, the basic technology was evolved steadily, and then in the TNGA, the combustion quality is improved. In other words, higher speed combustion is pursued, as well as the improved intake efficiency, so that this is now introduced in the common architecture, and this is the basic design of TNGA engine. And our target of development is to deploy it to all the engine models. So this is the concept of common architecture and module. As I explained to you earlier, that we can achieve the high power and the better the fuel efficiency at a higher level, and then the optimal combustion condition is created, and then its physical quantity is defined as a common architecture, and this common architecture can be applied to the different displacement engines, and then it's now reflected in the engine design specification. It's modularized, and by applying it to the different all the engine models based on TNGA, the production and development speed is accelerated, so that for different engines, the same type of the performance can be achieved. I'd like to show you the according to the sequence from 1 to 4 in this development. On the left-hand side shows the TNGA new engine targets physical quantity, and then in order to enhance the driving performance and fuel economy, y-axis and x-axis shows this the intake efficiency as well as this cylinder air tumble flow, which need to be improved at the same time. But those two elements, as you can see, are in the so-called trade-off relationship. In the new engine, this trade-off line is overcome. And at the beyond that level, you see the target of development. So combustion state should be the target optimal combustion state. So this is the optimal combustion state. And then you can see internal cylinder pressure, which actually is shown by this combustion waveform, which now is introduced in common architecture. So that in order to reproduce it in all the different displacement engines, you can see this reproduce the waveform of combustion. In order to modularize and deploy the optimal combustion, that we have identified this ideal port, the combustion chamber structure, which is reflected in the high tumble, high efficiency intake port, the morphology, as well as valve narrow angle, and then stroke bore ratio, and these are reflected in those specifications. And you can see that this is to be expanded to other engines. And in order to realize the ideal port morphology, which is linear, we developed the laser-cladded design in this manufacturing. So this is a laser-cladded valve seat. So when the valve is closed, this contact part, the seat part, now is applied with a thermal sprayed coating. To develop this, of course, we developed the alloy material as well as this new technology of the processing, which is called spray coating. We developed everything from scratch. And this new technology will be applied to and deployed to all the new engine models. As I told you, those main technology we developed, they are conventional high thermal efficiency and better fuel economy engines introduced. In the TNGA, we will have the direct injection through the multi-hole injector, which was newly developed, and then we have the trochoid, the variable capacity oil pumps applied as well. So all those additional new technologies added. Therefore, dynamic force engine has enjoyed the marked evolution. As a result, this is output as well the maximum thermal efficiency has surpassed the trade-off line, and then we achieved the world best levels. So through this initiative, that in the dynamic force engine, the drivers can enjoy and feel the attractiveness of driving performance, and from the low RPM to high RPM, the entire range of torque up is realized, and then so that all that exhaust performance is substantially cleaner as well.
Now, with regards to the new transmission, this time anew, we developed the front-wheel drive vehicles, direct shift 880 and direct shift 1080 for the rear-wheel drive vehicles. And for the harmony of environmental performance and direct and smooth, the themes for development were basic performance, that is improved transmission efficiency, exploitation of high-efficient engine range, and rhythmical and highly responsive gear changes. And to realize this, we made efforts to reduce the mechanical loss, also to expand the lockup range, and also the conversion to multi-shifts. First, I'd like to explain the improved transmission efficiency. And if you try to do multi-gearing, then there will be an increase in the transmission parts, and the transmission efficiency will go down. So in direct shift 880, 1080, we adopted gear clutch and technologies for efficiency, and we realized wide gear ratio in one of the world's best transmission efficiencies. Now, with regards to improving the transmission efficiency, in the development this time, we reviewed the design of component parts like gears and clutch from scratch, and went through the thorough reduction of the loss. And one of the technologies adopted is gear with ultra-finished tooth surface, and that is necessary for engagement. And the special tooth surface with longer lubricant life is necessary for engagement. And the fusion of design and production technology realized this gear, and we could further reduce the energy transmission loss when the gear engages with each other. Next, I'd like to talk about the initiative to expand lockup range. In the expansion of the lockup range, the issues are the booming noise at low revolution and reduction of vibration. Therefore, powertrain and whole vehicle were modeled. The factors for booming noise and vibration and the design specifications for effective reduction were numerically analyzed for the vehicle as a whole to expand the lockup range. Two technologies for transmission making the expansion of lockup range possible are introduced here. One is the optimal inertia distribution throughout the 80 gear, and to reduce the vibration, you need to enhance the 80 rotational inertia, but the problem would be the increase in mass. And this time, as you see in the figure, by changing the layout of the parts with assembly, the rotational inertia necessary to reduce vibration while maintaining the same mass is secured. And second is the new torque converter development. And on a component level, there is a detailed structural analysis, and that is reflected in the component specifications and optimally laid out high-ratio damper. New torque damper was developed, combining this with the multi-disc lock-up clutch and ultra-compact flat torus. The left figure shows the lock-up control range when driving and comparing it with the conventional AT. Pink is direct shift AAT, and at all gear change levels, you can run from lower speeds in lock-up state. Sudden engine revolution increase and irregularity in the number of revolutions during acceleration and deceleration were reduced, and improved response field was realized. Next, I'd like to talk about rhythmical and pleasant acceleration through conversion to multi-shift. For pleasant acceleration, equally spaced gear changes with a constant rhythm will be required. And in the direct shift 1080, we newly developed the close gear step for rhythmical and pleasant acceleration field. And to realize the rhythmical and pleasant acceleration, we also try to reduce the gear change time. And this issue is also how to we have to think about how to also deal with shock. And in direct shift 1080, highly responsible hardware were considered, and by combining with newly developed Powertrain model-based integrated control, we could have quick yet smooth and crisp gear change. Next, I'd like to talk about the new hybrid system. A new for 2.5-liter dynamic force engine, THS II for 2.5-liter combined with 2.5-liter dynamic force engine were developed, and the hybrid system aims for both environmental performance and direct and smooth. And this is hybrid systems newly developed for TNGA concept previous are deployed in various models. THS II for 2.5-liter combined with 2.5-liter dynamic force engine, and the multi-stage THS II and plug-in hybrid system were newly developed. And this is for the new THS II for 2.5-liter engines. It is based on the well-received THS II in the previous launched last year. And we newly developed a hybrid system in combination with the 2.5-liter dynamic force engine. Transaxle motor, power control unit, and batteries were all newly developed, and we achieved both fuel economy and road performance. Compared to the conventional models, there is an improvement in the powertrain for fuel economy 20% and also improvement of 10% of the mid-speed range acceleration. Next is the newly developed multi-stage THS II, and here we target the competing premium sports vehicles and realize the high road performance, and also at the same time realize fuel economy overwhelming competitors. Furthermore, we renewed the driving image of the conventional THS II, and we have even better high torque drive of the motor developed for hybrids. And in addition to the high acceleration performance, there is the 10-speed engine sound of gear change, which matches the rhythmical and comfortable acceleration feel. It is unfortunate that you cannot ride it and feel it for yourselves today. And for that realization, in the THS portion, there is an addition of the multi-stage shift device. And with this device, we could enhance the system output, and maximum engine output can be achieved from the low-speed range. And also in the fuel economy performance, this stage device is playing a big role. Maximum efficiency peaks are increased to 4, so that not only low speeds but at high speeds, transmission efficiency is greatly improved and fuel economy is greatly enhanced. Finally, I'd like to talk about the plug-in hybrid system for the new Prius. One-way clutch is added to THS with the adoption of dual motor drive system, and the generator is used as a motor, realizing a powerful EV driving. In the Prius PHV, compared to before, the EV output is 1.8 times bigger, and the maximum vehicle speed and drive power is also enhanced. And that enables EV driving in nearly all environments, including high-speed driving. Finally, I'd like to talk about the future development. With TNGA-based module development, we will introduce 19 models and 37 variations rapidly in the 5 years up to 2021. And following the Prius HV system and DirectShift 8AT, which are already introduced into the market, first of all, next year in 2017, there will be the combination of the 2.5-liter dynamic force engine and the DirectShift 8AT. And also, for the hybrid vehicles, there will be the combination of the dynamic force engine and 2.5-liter THS II, which will be introduced into the market. And we will continue to introduce into the market the newly revamped TNGA Powertrains. And against the estimates for the sales by 2021, 60% or more vehicles sold will be featuring the new Powertrains. And the plan is for 1 million vehicles annually to various regions in the world. And with this, we estimate a CO2 reduction of 15% or more annually in terms of powertrain contribution in 2021. Right now, we are developing the new generation Toyota Powertrains, and that is to attain a Toyota Environmental Challenge 2050, which is the next step, and in order to respond to the various needs in various regions and also for our customers' smiles. Thank you for your kind attention.